folks, welcome to the integumentary system. I think we're doing 5.1 and 5.2 to begin with, and we're done with and when I say we're done, I don't mean forget it, because everything builds on the first three chapters, or actually chapter 2 and chapter 3. But we're done with the atoms, molecules, and macromolecules. That was chapter 2. We're done with the organelles and cells. That was chapter 3. And we just finished tissues, chapter 4. Every other chapter in this textbook now is going to be an organ system chapter or supporting information for an organ system. So we're talking about organ systems here on out. And the first organ system we're talking about is the integumentary system. The integumentary system is basically your skin. And when you look at your skin, you can look at four main areas, really. The epidermis, the dermis, the hypodermis, which really doesn't belong to the skin. It's really superficial fascia, but we always study it with the skin chapter, so we might as well just keep on studying it with the skin chapter. And lastly, the accessory structures. These are structures that are like your sweat glands and your sebaceous glands and your ceruminous glands and your hair follicles and your erector pili muscles, etc., etc. So we're going to look at the epidermis layer, the dermis layer, the hypodermis, and then the accessory structures. All right, let's get started. The cutaneous membrane is simply your epidermis and dermis. That's your cutaneous membrane. The epidermis is 4 or 5 sublayers. I'll tell you the difference in a second. And the dermis is divided into the papillary layer, which is made of areolar connective tissue, and the reticular layer, which is made of, you would think, reticular connective tissue, but it's not. The reticular layer is made of dense, irregular connective tissue. So this is the cutaneous membrane part of the skin. And then the accessory structures are other structures found in the skin, like hair follicles and sweat glands and ceruminous glands and sebaceous glands, etc. So we'll talk about the cutaneous membrane and the accessory structures in detail. This is showing you the epidermis. The bottom layer of the epidermis right here follows the contours of what we call dermal papilla. These are dermal papilla. They're ridges inside the dermis. And this bottom layer of the epidermis is your mitotic layer, your stem cell layer. It's called the stratum germinativum, and we'll cover that in a second. So, by the way, because these are called dermal papilla, that's how I remember that it's the top layer of the dermis called the papillary layer, because there's dermal papilla in the papillary layer, whereas the reticular layer is underneath the papillary layer. So that's the epidermis and dermis. Now, these are the layers of the epidermis, and you need to know all 5 layers. And sometimes there's 4 layers. There's 4 layers in thin skin. And there's 5 layers in thick skin. And where is thick skin? It's the palms of your hands and the soles of your feet. So what layer does the thick skin have that the thin skin doesn't have? Or, in other words, what layer is missing in the thin skin? And the answer is the stratum lucidum. In fact, here's a good way to think of it. When you take a bath, the soles of your feet and the palms of your hands wrinkle. You get dishwater hands and dishpan hands and dishpan feet. Well, how come you don't get dishpan face and dishpan back and dishpan legs? Well, the thick skin is found in the palms of your hands and the soles of your feet, and it's the stratum lucidum that allows your skin to wrinkle and get dishpan hands and dishpan feet. But your forehead and your legs and your front and your back, they don't have that stratum lucidum, so they don't get that wrinkled appearance. All right, let's start from the bottom. The stratum basale, also known as the stratum germinativum, is your mitotic layer. This is the cells that divide. Germinativum. Sorry, I misspelled that. So this is the layer that divides. And when a cell divides into 2, one cell stays there as future stem cell, and the other cell starts moving its way upward. And it moves its way up, and we'll follow it up in a second. Also back in the stratum germinativum, you have melanocytes that are intercalated between the basal cells, the stem cells. So you might have 4 or 5 stem cells in a row, then a melanocyte, then 4 or 5 more stem cells, then a melanocyte. In addition, we have these specialized cells that receive signals like touch signals and pressure signals, well, actually just touch signals. And these belong to what we call secondary nerve endings, or secondary receptors, we sometimes call them. And in chapter 12 of AMP2, we'll talk about them. But these are cells that can depolarize and send a signal to your neurons. So these are sensory receptors. That's what they are, sensory receptors. These are also intercalated into the stratum germinativum. I don't know why I'm not spelling well today. It's not receptory, it's receptors. This is receptors. All right. When a cell divides into two, one stays in the stratum germinativum as a future stem cell, and the other cell moves its way up into the stratum spinosum. Now here's the thing about the spiny layer of the stratum spinosum. It's only spiny on a microscope slide. It's an artifact of slide preparation. In the body, the stratum spinosum is not spiny. What the stratum spinosum is a bunch of keratinocytes. That means cells making intermediate filaments made of keratin. Intermediate filaments are made of keratin, so we're making a whole bunch of keratin. These cells are connected by desmosomes, so there's no tight junction there, it's just desmosomes. But I say there's no tight junctions, but in a second you're going to see that we partially waterproof our skin anyway. So let's move up. The keratinocytes of the stratum spinosum keep pushing their way upward. And in the stratum granulosum we have granules. And these granules are called keratohyalin granules. This is what partially waterproofs your skin or makes your skin water resistant. These keratohyalin granules. And your stratum granulosum is where you start making them. Now, it's also the area where your organelles start to disintegrate. So it's the beginning of death for the cell. But they are cells filled with keratin and filled with keratohyalin granules. And then if you're in thin skin, as the cells move up, you hit the stratum lucidum. Now the stratum lucidum is a clear layer because it's translucent. It's not transparent, but it's translucent. This layer you can see through. And we also call it the glassy layer. It's only found in thin skin. It's not found in thin skin. It's only found in thick skin. It's not found in thin skin. And then lastly, when the cells move up, we become part of the stratum corneum. It's 20 to 30 cell layers thick. It's the thickest of the sublayers of the epidermis. Okay, be careful. The dermis is thicker than the epidermis. But if you're only looking at the epidermis, which of the 5 layers is thickest? And the answer is stratum corneum. It's really just a dead bag of keratin. That's all it is, a dead bag of keratin. And eventually at the top of the stratum corneum, you slough off those layers. And you just keep replacing them and keep sloughing them off and keep replacing them. All right. It's just 5 layers of the epidermis. All right, we have epidermal ridges, and these epidermal ridges that you can see here on an electron micrograph, a scanning electron micrograph, this is what gives us our fingerprints. Now, believe it or not, identical twins do not have identical fingerprints. Now, there is a genetic component to fingerprints. It sets up the basic patterns. But something else, I'm trying to write and speak at the same. Do not have identical fingerprints. There's something else that goes into making our fingerprints, and that is this. When you're a fetus, how you push against the inside of your mother's uterus, how you grasp your own hands, how you do things like that, affects your epidermal ridges. So identical twins are pushing against their own amniotic sac in different ways. And they even push against each other, and they push against the inside of their mom's uterus. Well, they don't do that identically. So their fingerprints change slightly from each other. They do have the basic genetic framework of similar patterns, but they modify these patterns in their behavior as fetuses. So identical twins do not have identical fingerprints, and that's why. There's pigmentation in our skin. What our skin would look like if it was completely translucent would be pinkish because our blood is red. But what our skin looks like because our skin is not translucent is it has some kind of color to it. Now this color comes from the melanocyte, but there's different pigments that can be made in the melanocyte. You can make eumelanin. That's brown. You can make pheomelanin, yellowish. You can make trichosiderin, trichosiderin or trichosiderin, pinkish or reddish, pink or red. Other things can add to your skin color, dietary things like carotene. You could have a disease state and have a lot of bilirubin in your body and you'd be jaundice, and that's a yellowish color as well, but it's an abnormal yellowish color. You don't want to be jaundice. So different things can affect your skin color. Now what we have going on here is a melanocyte producing melanin. Now the melanocyte has these pseudopods, these pseudopodia, pushing upward in the stratum spinosum. But not only do they push upward in different directions, but little granules pinch off the cell. These are called melanosomes, and these melanosomes enter the keratinocytes of the stratum spinosum. So this is why we don't look blotchy. I mean, if only the melanocytes contain the melanin, then you'd have a dark spot here, but then you'd have several layers where no dark spot. But what happens is these melanosomes scatter relatively uniformly, and you can see the 3-dimension too, relatively uniformly throughout the keratinocytes. And depending if you have a high abundance of eumelanin, you would be brownish color, versus if you had lower eumelanin and higher pheomelanin, you might be a more yellowish color. If you had low eumelanin and low pheomelanin, then you might be more of a pinkish color, and mainly because your bloodstream is showing through your skin more. Things like this. All right, here's what might surprise you. No matter what race you are, we all have about the same number of melanocytes. Doesn't matter if you're a very, very pale Caucasian or if you're a darker skinned person from another race. We all have about the same number of melanocytes. What's different is some of us produce a lot of melanin, and some of us produce very little melanin. That's what's different here. So the number of melanocytes is about the same. We have some disease states that affect our skin coloring. Addison's disease, for example, leads to high melanocyte stimulating hormone, which leads to a bronzing of the skin. And this has nothing to do with sunlight. Your skin bronzes in the absence of sunlight. John F. Kennedy had this disease. That's why his skin was so bronze all the time. He didn't go out and tan, but he had Addison's disease. You have vitiligo. This is the loss of melanocytes, and this occurs in patches. So you have patchy areas on your body that are whiter, and you have the normal area of your body with more melanocytes that is darker. This is vitiligo. This hand is a hand of a person with vitiligo. And that's it for 5-1 to 5-2. See you in 5-3.